It all began with a passion for speed, a creative spirit, and the desire to conquer the waves. Instead of choosing factory-made jet skis, I decided to take the harder path, designing and building my very own watercraft completely from scratch. From the very first sketches on paper, rough wooden panels, and old engines to the smallest mechanical details, everything was gradually brought to life through hard work, persistence, and the belief that there are no limits to dreams big enough to chase. In the first stage of the build process, all dedication was focused on creating the jet ski hull. Every horizontal beam, vertical support, and structural component was carefully measured, curved cut, and hand-assembled with high precision. Specialized polyurethane adhesive was evenly applied to the joints to strengthen bonding and reinforce the entire frame structure. The adhesive gradually filled every small gap, creating a solid connection between each part. Every drilled point and screw position at the joints was carefully tightened and finished, helping make the frame structure stronger, more stable, and more durable. Once the main frame was completed, the outer hull assembly officially began. Thin plywood panels were carefully measured, cut, and hand-fitted to follow the entire body structure. Build moved toward the complex curved bow section. Small wooden pieces were carefully cut and assembled like a complete puzzle, creating a smoother, stronger, and more aerodynamic jet ski body. Polyester compound was applied over the joints to fill gaps and reinforce the hull. The surface was then hand sanded to create a smoother and stronger body. Fiberglass cloth was carefully shaped along the hull curves before polyester resin was rolled on, bonding with the wooden structure underneath to create a strong and waterproof shell. Balance rails were installed along the bottom hull to improve stability at high speed. The entire surface was then reinforced with an additional fiberglass layer for greater strength and durability. Finally, the surface was coated to protect the structure, improve waterproofing, and give the jet ski a stronger appearance. The upper body was carefully shaped, slightly smaller than the lower hull, to create a connecting edge running around the structure. This design allowed the upper sections to fit tighter and more evenly with the lower body. Every cut, joint position, and body curve was carefully adjusted to maintain balance, improve structural strength, and create a smoother and more unified jet ski body. Each wooden section continued to be carefully assembled, glued and secured with screws with high precision, like pieces of a high-speed machine coming together. From the bow and seating area to the rear frame, every component gradually connected into a stronger and more balanced unified structure. Step by step, the handcrafted assembly process revealed the jet ski's aggressive curves and solid form, giving it a more powerful and performance-driven appearance. A reinforced support beam was installed beneath the seating area. Specialized adhesive was applied across the frame before the wide wooden beam was securely fastened with a nail gun to strengthen the upper structure. This component acts as the main load-bearing foundation, helping distribute the rider's weight more evenly while improving the stability of the entire seating area. The seating area was designed with a spacious layout, providing comfortable room for 2 riders while still being capable of supporting a 3rd passenger when needed. The load-bearing structure and technical dimensions were carefully calculated and adjusted to balance seating comfort, stability, and overall jet ski performance. Thin, flexible wooden panels were precisely cut to match the hull frame before being installed onto the deck. Each panel edge was carefully secured with a nail gun and smoothly fitted along the body curves, gradually creating a smoother, more seamless, and stronger deck surface. Small gaps around the joints were filled with polyester compound to reinforce the entire hull structure and smooth the surface. After careful sanding, fiberglass layers were applied inside the hull to improve strength and waterproofing throughout the structure. Once the upper body surface was fully smooth, an epoxy primer coat was applied to protect the structure before finishing with the exterior paint layer. A completely new challenge began with the fabrication of aluminum components for the jet pump system. Design templates were attached directly onto the aluminum surface before each pump was carefully cut out using a specialized jigsaw. Each cut followed the design contours smoothly, gradually revealing the first jet propulsion components. After the edges were smoothed and cleaned of burrs, the aluminum sheets began to be bent and shaped into cone-like forms for the jet propulsion system. Without specialized bending machines, a custom handmade jig was built directly on the welding table to securely hold and accurately shape each aluminum component. Once the aluminum panels were fully shaped, the first jet intake section was welded together and carefully aligned into position. This is one of the most critical and complex components, as the entire pump and rear drive shaft system must be perfectly aligned with this section. The intake section was designed to smoothly guide and accelerate the water flow before it reached the impeller, helping reduce turbulence and minimize cavitation inside the jet propulsion system. The rear circular section was then carefully aligned and connected directly to the jet pump assembly, creating a smoother and more stable water flow channel. Once the intake section was completed and properly aligned, the steering system for the jet propulsion unit continued to be assembled. The rear jet nozzle was designed to direct the high-pressure water flow from the pump, helping control and change the jet ski's direction while operating on the water. A reverse gate system was also integrated at the rear to redirect the water jet forward, helping the jet ski slow down and move backward more smoothly. The entire assembly gradually came together, forming a powerful and responsive control system for the jet-powered watercraft. The jet impeller assembly and drive shaft continued to be installed, forming the main propulsion system of the jet ski. The impeller draws water from beneath the hull and accelerates it into a high-pressure jet stream to generate thrust for the entire craft. The entire impeller assembly was housed inside a pressure pump casing and directly connected to the central drive shaft, allowing engine power to be transferred to the jet propulsion system more smoothly and efficiently. A large opening was carefully cut into the bottom hull section to install the jet propulsion system. The cut edges were then reinforced with resin and fiberglass to improve strength, waterproofing, and load resistance around the mounting area. Once the surface preparation was completed, the aluminum jet assembly was aligned and secured using high-strength adhesive combined with fastening screws, allowing the entire system to be firmly mounted onto the hull structure. Once the jet propulsion assembly was fully secured to the bottom hull, one of the most critical and difficult stages was nearly complete. The entire system was precisely aligned and firmly secured using high-strength adhesive and tightened bolts to ensure stable high-speed performance on the water. Once the jet propulsion assembly was fully secured to the hull, one of the most difficult stages was nearly complete. The entire system was carefully aligned and fixed, as even a small misalignment could affect high-speed performance. Now it was time to equip the jet ski with its true heart, a superbike engine capable of exceeding 12,000 revolutions per minute while remaining compact and lightweight, promising outstanding power for the entire jet propulsion system. Using a superbike engine for the jet ski was a bold choice, delivering strong performance, impressive speed, and a more efficient cost for the entire project. This 4-cylinder engine is expected to produce around 180 horsepower, an incredible amount of power capable of turning the custom jet ski into a high-speed machine ready to tear across the water. To withstand the power and heavy vibration of the superbike engine, the heavy-duty steel support frame continued to be fabricated, fully welded, and securely mounted to the hull. Rubber dampers were also installed to absorb vibration, reduce shaking, and protect the entire structure during high-power operation. An additional steel support frame and bearing mount assembly continued to be fabricated and welded inside the hull for the drivetrain system. The entire structure was precisely aligned and firmly secured to keep the drive shaft stable, reduce friction, and minimize vibration at high speed. The pillow block bearing assembly continued to be installed to support and keep the drive shaft aligned during high-speed rotation. This component helps reduce friction, minimize vibration, and keep the entire drivetrain operating more smoothly and stably. Instead of using a traditional chain or gearbox system, this setup uses a wide belt drive design. Power from the superbike engine is transferred through a V-belt and large pulleys, allowing smoother and quieter power delivery. As the system operates, all engine power is transferred directly to the central drive shaft before driving the rear jet propulsion assembly, creating powerful thrust for the jet ski. As the build moved into the exhaust system stage, things became far more complex since the original exhaust manifold no longer fit inside the hull structure. The entire exhaust layout had to be redesigned using curved steel pipes to create a completely custom manifold system. The goal was to merge all 4 exhaust outlets into a single main pipe, requiring extremely precise measuring, cutting, and alignment so the entire system could fit together cleanly and operate properly. The exhaust header continued to be fabricated by aligning and welding all 4 exhaust runners into a shared system, helping maintain smoother and more stable exhaust flow. After that, the main 60mm collector pipe was completed to merge all exhaust flow into a single outlet, optimizing flow and reducing restriction during high-power operation. The waterlock system was built to serve as both a muffler and a cooling chamber for the exhaust system. The waterlock system was built to serve as both a muffler and a cooling chamber for the exhaust system. The exhaust system continued to be completed by adding water inlet fittings directly into the main pipe. Small tubes were welded in place to create a cooling circulation system that helps reduce heat and protect the entire exhaust system during continuous operation. An additional steel support frame was welded to secure the cylinder head, reduce vibration, and maintain stability for the entire drivetrain system. The structure also integrates a mounting tray for a high-performance AGM battery designed for harsh jet ski operating conditions. The ignition coils, starter switch, electrical wiring, and fuel supply were finally fully connected in preparation for the engine's first startup. All the essential systems required for operation were now ready, and the biggest question remaining was whether the engine would truly come to life and run successfully. The cooling system continued to be connected to protect the engine and exhaust during operation. Test water was supplied directly from a garden hose to maintain continuous cooling. The seat frame construction began with assembling and shaping the basic support structure for the entire design. As the build moved into the curved sections, a series of parallel grooves were cut into the plywood surface to release internal tension, allowing the panels to bend smoothly and follow the intended shape without cracking. Once the plywood sections were bent and trimmed to match the intended design, the seat frame was assembled and secured into a complete structure, making the entire seat stronger and more seamless. The frame was then prepared for fiberglass reinforcement to improve durability, water resistance, and overall load-bearing strength during real operation. Once the fiberglass reinforced frame had fully hardened, a soft foam padding layer was glued and fixed onto the seat surface. This layer provided comfort, shock absorption, and the necessary thickness for the seating area. Next, the excess foam along the frame edges was trimmed using a heated knife to create cleaner and smoother contours. The entire foam surface was then carefully hand sanded to soften the edges and refine the seamless shape before the final upholstery stage. The final seat finish featured a premium marine blue artificial leather layer. The material was carefully stretched and aligned over the foam padding, creating a smooth, tight, and clean surface across the entire seat. Beyond its modern appearance, the upholstery also provided excellent water resistance, wear resistance, and durability for harsh marine operating conditions. An important next stage involved building the mechanical control system for acceleration and reverse operation inside the cockpit. The lever mechanism was fabricated from carefully machined metal tubing, allowing the assembly to slide and operate smoothly during control movement. The upper section served as the driver's control handle, while the opposite end was mechanically connected to a reverse control cable that transferred movement to the rear reverse system, allowing easier handling and maneuvering of the jet ski. The reverse steering system was installed directly above the jet nozzle, allowing the water flow to be redirected for slowing down and reversing when needed. To ensure smoother operation, an anti-binding bearing was integrated into the drive mechanism to provide more flexible and stable movement. The control cable was directly connected to the reverse mechanism, allowing the rider to easily operate the reverse function from inside the cockpit. As the lever moved, the pulling force was transferred to the reverse gate behind the jet nozzle, redirecting the water flow and controlling the jet ski's thrust direction more effectively. When the rider lightly pulled the control lever, the system moved into the neutral position. Pulling the lever further backward activated reverse mode, while the control cable lowered the reverse gate to redirect the jet water flow and change the thrust direction of the craft. For safety, the mechanism also included a spring-loaded return system that automatically brought the reverse gate back to the default forward position. This design prevented the system from getting stuck in reverse if the control cable lost tension or failed during operation. A reinforced rear grab handle was installed at the back of the hull to provide passengers with a secure grip during acceleration, cornering, and rough water movement. The structure was directly mounted onto the hull to ensure stability and load-bearing strength during operation. Below it, ventilation openings and protective mesh panels were added to improve airflow, assist engine cooling, and prevent debris from entering the system. The next stage involved fabricating and installing a reinforced passenger grab rail at the rear section of the hull. This component acted as a strong and secure handhold, helping rear passengers remain more stable during acceleration, cornering, and rough water movement. Instead of holding directly onto the rider, passengers now had a dedicated and more reliable support point throughout operation. Beyond improving riding stability, the grab rail also made climbing back onto the jet ski from the water easier and safer thanks to its durable load-bearing steel construction. The fabrication process began by measuring, trimming, and bending the steel bars to shape the grab rail frame so it perfectly matched the curves of the rear hull. Each section was carefully aligned to allow the structure to sit naturally and seamlessly on the body surface. Once every part was properly positioned, the entire frame was fully welded together into a rigid load-bearing structure. Weld strength and durability were treated as top priorities to ensure the grab rail could withstand heavy pulling forces and vibration during real-world operation. Once the grab rail frame was completed, the wooden handle sections were cut, shaped, and sanded to fit perfectly along the rail before being fixed onto the steel structure. The wooden parts were bonded using waterproof adhesive, improving durability while giving the jet ski a unique handcrafted appearance. Once all components were ready for finishing, a specialized coating was sprayed across the entire surface using a deep blue finish. This paint not only enhanced the appearance, but also provided strong water resistance, UV protection, and improved durability against harsh marine conditions. To create a more unified design, the same blue tone was also matched with the seat upholstery, giving the entire jet ski a cleaner, more modern, and professional appearance. The main body of the jet ski was coated in a dominant white finish, creating a clean surface that highlighted the sharp contours and design lines of the hull. Over the white base, blue and black graphic accents were added to create strong visual contrast. This color combination gave the jet ski a sharper, more dynamic, and sportier appearance. Anti-slip rubber mats were applied across the deck floor to improve grip and help the rider maintain better balance on wet surfaces. A marine-grade rubber edge trim was then installed along the joint between the lower hull and upper deck to create a watertight seal and protect the entire hull structure during operation. From rough sketches, raw materials, and countless adjustments, the entire project had gradually transformed into a real jet ski. Throughout the build process, there were many difficult moments, mismatched parts, and repeated reworks. Yet, those challenges became the true value behind this handcrafted creation. Now, after months of fabrication and dedication inside the workshop, only one final moment remained ahead: the very first water launch and real-world test of the completed jet ski.